this topic, which was a cooperation with TU in Braunschweig. So those of you who have already visited the session before will find some similar terms in there. So first of all, what are we dealing with? Feature-oriented development is the main domain we're talking about, and especially specifically feature models. And feature models always, feature models always represent the commonalities and variabilities of some product line, of a product, of some software. In this little example here, we have this pick and place unit, which is very commonly known. And those feature models, however, are always represent a very static view on how a system looks. So it represents the state of the product at a certain point in time. But in real industry examples, feature models evolve over time and grow while new features are added due to customers or requests or changing requirements. So the feature model and the system behind it get bigger and bigger. And you always have this snapshots of the systems of how they'll look at a certain point in time. What you're kind of missing is, well, how did we get there? How did we grow so fast? And, well, even where are we going to in the future? So this is the point where you need something more evolution aware, and this is where temporal feature models and temporal feature modeling comes in. So these are feature models which also extend into an additional dimension, which is the evolution, which can be time or a version over which a feature model evolves over time and changes. So a little example here I have is you start out at a certain point in time with these feature models, and after a while you add a new feature there. And after another while, well, things change, so this feature which was first a mandatory feature changed to be an optional feature. And after a while again, you might add another feature as well. So in the end, you just see this feature model, but there is a lot of steps going there. So there are a lot of approaches which are already trying to create feature-aware feature models, evolution-aware feature models, sorry. And we have analyzed the existing approaches and tried to find, well, what have they in common, what are the differences. And in the first step, we looked at, well, how do they try to support evolution? Many approaches are looking at the concrete feature implementation, whereas also some, but not many, also try to care about the feature model itself and the features and version them or add them depending on time or version. So we compared them, the characteristics of those systems, and again tried to identify commonalities to harmonize these. So, for example, most of them in some way try to take care of feature model evolution, although in very different forms. For example, this one, the EvoFM, still uses the common commonly known feature model notation of optional, mandatory, and variation, but not to add a time as evolution step, but the model, the evolution itself. So if a feature gets removed or is added after a time, this becomes an optional feature because it was not present all the time, for example. We also there's a lot of them also taking care of artifact implementation, as I already said. However, in this harmonization approach we're going to show you, we did not include artifact implementation. Why? Well, because all of them do it absolutely different, so harmonizing them is practically impossible. So what we're focusing on here was the actual feature model itself and all things evolving around the feature model. So our goal is now to take all these approaches and harmonize them to give an API or ecosystem, as we later call it, to be able to perform common research on all these different approaches. Well, how did we take this? Do this? Well, we take this analysis of the different systems and extracted a set of requirements to build an API on to harmonize this. And well, I will shortly go through them. The first requirement, you need to be able to create, well, an arbitrary non-temporal feature model. This is, for example, for the EvoFM approach thing. So you need to be able to just, without any time concept, add features and operate in a normal feature model way. The second one is then the actual temporal context. So you need also to be able to create and evolve then the temporal feature model. And this means you have some temporal context, meaning a timeline or even revisions. So you add a feature with at a certain point in time, for example. The third requirement would be, well, evolving feature models with temporal feature model support. What does that mean? Well, would be very nice for, let's say, feature IDE users to still have our API behind them, and while developing a very commonly known non-temporal feature model, at the same time also create a temporal model behind it. So if you just work in a non-temporal context, but in the background you create timestamps for each operation on the feature model. The fourth requirement is different views. So what does it mean? Basically, well, we need to be able to transform between the different views from temporal to non-temporal, and well, and the other way around, of course. So it means you basically transform this temporal context model into a snapshot version of itself. The next point is access to evolution operation history. Well, what does this actually mean? Well, basically, you want to be able to register third-party observers to the model and get informed if something happens. So if a feature might get added and so on, it would be very useful for different kinds of transformations you might want to do, or even handling something for the artifact evolution. The sixth one is the replay evolution. Well, what does this mean? Well, you have a domain developer is developing a feature model over a certain point of time. And what we do is, in our API, want to do is record the action that takes place. So without transferring the entire feature model, other developer can get just this history, and starting from the same origin point, he could recreate or similar in this case, recreate what the other developer has done. Analyzing evolution, well, no nice pictures for this one, but analyzing the feature model is what, well, most of us do in some different research cases. So this is basically the key point why we're doing all of this, so that we can apply different analysis methods on our feature models, no matter which actual approach you originally were using. And the last one that was coming from, well, some of the approaches want to control, so some of these approaches are actually industry related. So what they want to do as well is, of course, control who has access to certain operations on a feature model, meaning if you have two different developers, a domain engineer and some application engineer, you might not want to have the application engineer just randomly deleting features from the feature model, but the domain engineer can. So to realize that, we created an API which is based on two layers. You have the temporal layer and the non-temporal layer. And then we have very different views on this API, basically. So on the top, we have our SPL managers, so the guys using SPL tools. What our API realizes here is they can use any arbitrary tool they are used to, meaning feature ID or whatever, and still work on a temporal or a non-temporal context, no matter whatever they want to do, basically. And our SPL developers, so the guys developing tools, are just working on the data model of our API, which has a version which is non-temporal and a part which is temporal. And the point where they are joining is the notion. So this is the core of our API, more or less. There you create the specific notion instances for each of these different implementations we presented before. So you could have one supermod user which develops his software using supermod, but is actually then changing to something like Force or Darwin SPL in the background. So what our API now does is he can use any arbitrary tool which is built on our temporal or non-temporal feature model data structure, which is implementing our notion. And this part is basically then independent of any temporal feature modeling notation. And this part is the only part which requires a lot of work for the Notion developer to actually create the bindings to their third-party tools. Well, regarding our research questions, we thought about two things. First of all, the expressiveness, so which functionality regarding feature model operations could we cover? What were the difficulties and the experiences when implementing this notion layer we showed for specific TFM notations? And the second is utility, so can our temporal feature modeling ecosystem satisfies the needs for the developers in concrete scenarios? So applying our the operations, exchanging different backends, and still can do the same things. So first, the expressiveness. What did we do? Well, we did some implementation of our API. So for Force, for Darwin SPL, which are both temporal, and as those are two, we had only the only access to the full API. We also added some non-temporal API implementations to test this transformation between temporal and non-temporal feature models. And yeah, we measured the effort we needed in lines of code to implement the API and the number of notion-specific calls which would be required anyways to execute the operation on the specific notation. So here are all the operations we implemented. So it's very basic, from creation of features, feature models, adding features, moving, removing, and so on. And for Darwin SPL and eCore, Delta eCore, we had no significant problems, meaning, well, that is the line of code we required to have it implemented in our API. And this is the amount of calls you required anyway to execute this certain operation in Darwin or in Delta eCore. The only little overheads we had here is due to some special handling of changing relations and so on. Nothing dramatic. For Force is a bit different. We had some challenges because Force is mixing temporal and non-temporal aspects of feature models, because you don't add features specifically at a certain point in time or revision, but it's automatically evolving with each operation you execute. And yeah, that's the main problem why we had some additional lines for many of these operations here. Feature ID and prevariance, so the non-temporal aspects. Well, also there are of course some additional work to do because, for example, they don't have this concept of groups. Groups is what, for example, is an AND group, and is a group where features are optional or mandatory, and this XOR and OR groups. So the concepts here where you define constraints between features, as we decided in our API to have a group as abstract object for that. And dealing with that required some additional lines of code. But in the end, which brings us to the second part, the utility, we created for two different case study systems, the pick and place unit and Turtlebot, two scripts which basically contain the evolution of the SIFT systems over time, and replayed it with our temporal feature model API, where we exchanged the back end of the temporal feature model API for each run. And in the end, we compared, well, did we get out the same feature models for each of those different tool notations? And yeah, actually we did. So to summarize, well, temporal feature models have obviously the advantage of having the entire history of the feature model itself stored with it. There are many different approaches already trying to solve evolution and feature models together. And well, we implement it now in API, which allows to harmonize all these approaches in the hopes that in future it might be easier to compare results, especially if we're considering analyzing the evolution of software product lines and more, of course, whatever future research requires us. Thank you.
Sorry if I missed it in the talk, but were there any features that you ran into for any of these systems that you, in your API, decided not to model because they weren't of use for the... that was covered?
No.
Okay. So, that weren't used in the models that you were using, but that are supported by the systems, and that would be of interest.
work as a chance to make choices. Or you could say, well, we want to leave out these features because in retrospective, we don't want to have